climate change, the accelerating energy transition. I mean, these are huge global challenges, right?
Absolutely huge.
We all hear about needing more solar, more wind, but here's the really interesting bit, the tricky question. How do we actually plug all that renewable energy in, without the whole power grid becoming unstable?
Uh-huh.
How do we keep the lights on reliably?
Now, that's the core problem.
So today, we're going to do a deep dive into this idea of flexible generation. We've been looking at a brochure from ENGIE, a big energy player, and it really helps unpack the solutions.
It does.
Some are kind of the unsung heroes. Others are genuinely surprising ways we can make this renewable revolution actually work. I think you'll find some real aha moments here.
Yeah, it's definitely a complex picture. And, the pressure is on. COP28 in Dubai, it was quite clear we have to move away from fossil fuels.
Right.
And crucially, triple global renewable capacity.
Triple? That's massive.
It is. And the change is happening fast. I mean, solar and wind capacity, it jumped 50% in 2023 alone compared to 2022.
Yeah. Wow. 50%.
But that speed, that massive increase, it brings us right to the critical challenge. We need new flexibility solutions. We absolutely have to have them to manage the variability of renewables.
Okay, so variability. Why is flexibility the answer then? What does that really mean in practice?
Well, as renewables become a bigger slice of the pie, they cause these pretty significant swings in electricity production.
Right. Sun doesn't always shine, wind doesn't always blow.
Exactly. Both seasonally, like winter versus summer, and daily, even hour by hour. So grid operators, they have to adopt flexibility solutions. It's the only way to ensure the grid stays stable, stays reliable.
So it's about balancing things out.
Precisely. Balancing the ups and downs in renewable generation and matching it with our demand, which also changes all the time. And the key message from the source, which I think is really important to underline, is that there's no single magic bullet here.
Ah, right.
No one technology solves it all. It has to be a combination of different approaches working together.
Okay, a combination. So if it's a multifaceted approach, flexibility is sort of the main lever ENGIE is pulling.
That's how they frame it, yes.
It's really interesting to see how these different solutions fit together to tackle this puzzle. Let's pull back the curtain then. What are these key pillars of flexible generation?
Where should we start?
Well, first up, let's talk about thermal power, natural gas. Its role seems to be evolving, right? The source is it's still an essential component.
Yeah.
How does it provide flexibility?
Yeah, that's a good place to start. The practical benefit is, well, these plants can generate a lot of electricity when needed.
Okay, sheer volume.
Volume, yes. And maybe more importantly for flexibility, they're easily controlled. When they'll start up, how quickly they can ramp up or down. It's reliable.
Predictable.
Predictable. And yes, natural gas has lower CO2 emissions than, say, coal. But, and this is important, ENGIE is actively looking at ways to decarbonize these thermal operations further. It's part of their big goal. Net zero by 2045.
So they're not just sticking with gas as is.
No, definitely not. They're looking at several strategies, things like carbon capture, storage, and utilization CCUS.
Captured into CO2.
Right, trapping it.
Yeah.
Also exploring alternative fuels, not just hydrocarbons, and making the plants themselves more energy efficient. Plus, using AI and data, to optimize everything and cut energy losses. It's about making gas power smarter and cleaner.
Okay, so gas has a role, but it's changing. What's next? Battery storage. This sounds like the quick reaction force for the grid.
That's a great way to put it.
The need is growing fast as renewables ramp up, right? But how fast is fast? And what kind of batteries are we talking about?
The speed is the key thing here. Batteries can respond to grid demands incredibly quickly. We're talking seconds.
Seconds, wow.
Yes, within seconds. They can do it multiple times a day. That makes them ideal for what's called intraday balancing, smoothing out those really short-term fluctuations.
Yeah.
Plus, their capacity is going up, costs are coming down every year, so they're becoming more and more competitive, especially the source nodes, when renewables make up more than, say, 30% of the grid's power.
Right, that seems to be a critical threshold.
It is. And there are different types of these battery energy storage systems, or BES. You've got grid-connected ones. Some are standalone. They just charge from the grid, discharge back when needed.
Okay.
Others are co-located, like right next to a solar farm or wind farm. They store the energy produced there and then feed it into the grid later.
Makes sense. Store it at the source.
Exactly. And then you have demand-side batteries. These are customer sites, could be a big industrial plant, could even be in homes eventually.
Ah, so closer to where the energy is used.
Right. They store power from the grid, maybe from rooftop solar panels, and
Got
then use that stored energy locally, or maybe feed it back to the grid.
it.
It helps manage demand patterns.
Interesting. Okay, gas, batteries. Now, for something I found genuinely surprising, desalination, making fresh water. How on earth does that help with grid flexibility?
Yeah, it's not the most obvious one, is it?
Not at all.
But it's actually quite clever. The flexibility comes from decoupling desalination from older thermal power plants and increasingly powering it with renewables.
Okay, how?
Well, think about reverse osmosis, RO technology. It's one of the most energy-efficient ways to desalinate, but it still uses a lot of electricity.
Right, it's energy intensive.
Very. So when you have lots of cheap renewable power available, maybe it's super sunny or windy, these desalination plants can ramp up production. They effectively act as a huge sponge, soaking up that excess electricity.
Ah, like a controllable load.
Exactly. And conversely, if renewable output dips or grid demand is high, they can scale back their operations, reducing their draw on the grid. It adds flexibility on the demand side.
That's clever, using a water process to balance power.
And RO is great for this because it needs less energy than older methods, which cuts costs, and it's very scalable. You can build plants to meet different water needs.
And ENGIE is big in this space, especially in the Gulf region.
Oh, absolutely. In the GCC region, the Gulf Cooperation Council countries, they operate 13 large desalination plants
13.
using cutting-edge tech. They produce about 5.8 million cubic meters of water daily.
That's a staggering amount of water.
It is. It serves over 14.5 million people every day with drinking water. But for our discussion, the key is how these massive energy-hungry plants become these strategic assets for managing the power grid itself.
Amazing. Okay, fourth pillar, renewable hydrogen. We hear a lot about hydrogen. It's talked about for decarbonizing heavy industry, transport, and storage capabilities.
Yes, storage is a big part of its potential.
How is it made renewably, and what's its role in flexibility?
So renewable or green hydrogen, it's typically made using water electrolysis. You use renewable electricity like surplus solar or wind power to split water into hydrogen and oxygen.
Okay, using excess renewables.
Exactly. And its role is multifaceted. First, it can store energy for long durations, much longer than batteries. Think weeks or even months. So it can provide power when renewables aren't available for extended periods. That's crucial for seasonal shifts.
Seasonal storage. That's the holy grail, isn't it?
It's certainly a major challenge batteries struggle with. Hydrogen can also fuel sustainable transport, help decarbonize industries like fertilizer production, refineries, chemicals, and crucially for the grid, it helps integrate those intermittent renewables by providing a way to store massive amounts of surplus electricity that might otherwise be curtailed or wasted.
So ENGIE is involved across the whole hydrogen chain.
Seems so. From producing the renewable power needed to making the hydrogen, storing it, and developing its end uses, it's positioned as a really versatile energy carrier for the future.
Okay, so we've covered gas, batteries, desalination, hydrogen, all ways to manage the production side or store energy. But the source also stresses that production flexibility isn't the only answer.
That's right.
Demand can also be adjusted. Which brings us to demand-side management. How does that work? Shifting when we use power.
Exactly. It's about making consumption flexible too. For example, big industrial or commercial customers, they can actually benefit from shifting their energy use.
How so?
Well, imagine a factory running its most energy-intensive processes during times when renewable energy is plentiful and cheap, maybe overnight using wind power, instead of during peak demand hours.
Right.
With electricity prices getting higher, there's definitely more interest from businesses in these flexibility reward offers. They get paid or save money by being flexible.
Incentives to be flexible.
Precisely. It's becoming a standard part of energy efficiency strategies globally.
And does this apply to us regular folks at home too?
It's starting to. New services are emerging to help manage household appliances. Think smart thermostats, EV chargers, water heaters.
Ah, the smart home stuff.
Yeah. The idea is you can save money on your bills and help stabilize the grid at the same time. It's quite compelling. ENGIE estimates in their European decarbonization scenario that by 2050, flexibility from the demand side could be twice as high as flexibility from the production side.
Twice as high. Wow, that's a huge shift. Puts a lot more emphasis on the consumer's role.
It really does. It changes the dynamic significantly.
So pulling all these studs together, It's clear this isn't about finding one perfect solution, is it? It's this intricate combination.
Absolutely. It's a portfolio approach. Each technology plays a different role, often on different timescales.
Right. Can you give us a sense of those timelines?
Sure. So battery storage, that's accelerating really fast for those immediate second-to-second up to daily flexibility
Okay,
needs.
short term.
Then you have pump hydro storage. That's a mature technology. Been around ages. Good for hourly to maybe weekly flexibility.
Medium term.
Kind of. Then the gas turbines, the CCGTs we talked about. They're mature. Their overall share might decrease, but they're still valuable for intraday, up to seasonal needs, providing that longer duration backup.
Longer backup.
And finally, hydrogen production and storage. That's still emerging, but it's really seen as the key for true seasonal flexibility. Storing summer sun for winter, essentially.
It's fascinating how they fit together. And it's striking that a huge company like ENGIE with, what was it, 16,000 employees
Yeah, globally.
and 62 gigawatts of gas power,
Yeah.
that they're so invested in this transition and all these other technologies.
It really shows the direction of travel, doesn't it? And that's not about just shutting down gas tomorrow, but evolving its role, making it cleaner, using it more flexibly, alongside this massive build-out of renewables and storage.
So what are their big goals looking ahead towards 2045?
Well, their objectives are pretty ambitious. Definitely continuing to decarbonize those gas plants, exploring different fuels, more CCUS. A huge target for battery storage.
1 terawatt hour capacity.
1 terawatt hour. That's enormous. It really is.
Yeah.
Shows the scale needed. Also, significantly developing green hydrogen production. Expanding desalination capacity to 2,000 million imperial gallons per day.
Wow.
And just continuous optimization using digitalization, AI,